Let's share our screen. We're doing that. Okay. So let's see, where was I? Come back here. Week 14. Man, we made it so far. Okay, week 14, y'all. So let's see. Today, what I'm going to do, y'all, we're going to go over 10.1 and 10.2. They're not real long sections. I think in the homework you have 4 or 5 problems for each. So you got a total of anywhere between 8 to 10 problems. Let's see. Homework for 10.1, y'all, is due. It's supposed to be next Monday, the 29th. I put 11/2, so let's fix that. And let's go here. Next Monday will be the 29th. There we go. And for 10.2, I'm making it due the following Monday, December the 6th, okay? I also, let me see, let me save that part there. I also have set up the review and Alex. So the review has 44 questions. I haven't made the final exam just yet, so I'm going to work on that in the next few days. But I am, again, what I'm going to do, y'all, just like the way we did test 1, test 2, I'm going to pull problems directly from the review, okay? And so what I did is I took the same exact questions that we had on test 1 and on test 2. I added those to the review, and I took problems from 8.3, 8.4, 8.5, and then these 3 sections in chapter 10 that we kind of have to finish up. Wednesday, y'all, we won't actually meet here in person. What we'll do is I'll have a Blackboard Q&A session. Like I said, it's the day before Thanksgiving. I don't know if any of you all are planning on going out of town, or if you have people coming in, or you just need to, get things ready at home for the big day. So I don't want to cover, like, I don't want to do 10.3 and say, okay, look, I covered it, and then you were getting stuff ready for Thanksgiving. So we'll save 10.3 for the following week, okay? So I'll sign in, y'all, at 2 o'clock, and I'll be on from like 2. Nobody signs up, like, say by 2:30, I'll go ahead and log off. But if you got questions and you need help with something, let me know. All right, so let me pull up the notes for 10.1. So we're going to talk a little bit about ellipses today. So let's see, let's do this. Let's open this guy up. And where is it? There we go. Come on now, let's print this thing to our OneNote right here. Here we go. That's when we want to go. Okay. All right, so let's get started here, y'all, on 10.1, which is, again, the ellipse. So what chapter 10 talks about, y'all, are these things called conic sections. And conic sections derive their names because each is the intersection of a plane and a double mapped cone, okay? So you can see here's the circle, right? It's just kind of like we're taking, a lot of times they call these things cross sections, right? There's the ellipse. You can see that takes it like at an angle. We have hyperbolas and parabolas, okay? So let's take a look here. It says the definition of ellipse is a set of all points x and y in a plane such that the sum of the distances between that point and 2 fixed points is a constant. The fixed points are what we call the foci, which is the plural of the focus of the ellipse. Okay, so the line through the foci that intersects the ellipse at 2 points are called the vertices. And the line segment with the endpoints at the vertices is what we call the major axis, and the center is of the ellipse is the midpoint of the major axis. And then we have a line segment that's perpendicular to the major axis, passing through the center of the ellipse with endpoints is called the minor axis, okay? So let me just kind of scroll up here so you can see what we're looking at, right? So the basic shape of an ellipse, you can see it here. It's kind of like a circle where we kind of squash it either this way or we kind of squeeze it in from the sides, right? So either the circle kind of gets elongated either horizontally or it gets elongated vertically. So when it's elongated horizontally, meaning it gets wider like this, then this is what we call the major axis, and those are the vertices right here where they intersect. Those are the vertices of the major axis, and then this one are the vertices of the minor axis. And then if we take that ellipse and we elongate it vertically, so kind of like we squeezed it in, right? Like it had 2 sides squeezing it in. then this is the major axis vertically, and the minor axis is now horizontal, okay? So we have what we call standard forms of an ellipse centered at the origin. So this form here, y'all, is when the ellipse is centered at the origin. Remember, the origin is the 0, 0 point. So it says, the first part, it says, assume A is bigger than B and it's bigger than 0. So what does that mean? That means A and B are positive numbers because they're both greater than 0, but A is bigger than B. Okay. If A is bigger than B, then when we have this form, x squared over a squared plus y squared over b squared is equal to 1. The center is at the point 0, 0. The foci are the points C0 and negative C0, and this is how we're going to find our foci. The endpoints of the major axis are A0 and negative A0. The endpoints of the minor axis are 0b and 0 negative b. And this is what the graph looks like. And similarly, we have what happens when the major axis is the y-axis, okay? The center is still at the point 0, 0. The foci is now the point 0c and 0 negative c. The endpoints of the major axis are 0a and 0 negative a. And the endpoints of the minor axis are b0 and negative b0. Okay, so what we're going to do is we're going to use this here to see if we can graph the ellipse. We want to find the center, the foci, and the vertices. Okay, so all I'm going to do is I'm going to kind of zoom out a little bit. I'm going to be kind of going back and forth so we can see what's happening here. Okay, so I'm going to do it like that. And I'll just do my work in this kind of middle region here, y'all. Okay, we want to find the center. So remember, the center of these are all centered at the origin. So the center here, y'all, is just the point 0, 0. Okay, so we got the center. Now we want to see if we can find the foci. So I want you to notice right here, it says the formula for the foci is c squared equals a squared minus b squared. So I'm going to write this down. C squared equals a squared minus b squared. And what we need to identify, y'all, is we need to identify the values a and b. Okay? So what I'm going to do is I'm going to scroll back down here, and we got to figure out is our ellipse going to be with the major axis as the x-axis or the major axis as the y-axis? So what we need to figure out is we're going to compare the numbers a and b, okay? So number one, a and b are both positive, and we know that they're both positive, right? But the number a is bigger than the number b. So I want to ask you a question. If you look down here, between the 25 and the 4, which is the bigger one? The first one, right? 25. So this is going to be more like this one here, right? All right, so let's see if we can figure this out. So I'm going to come back over here. All right, so let's see if we can do this. C squared equals a squared. So a squared, y'all, is already that number right there. I'm going to write this on the side. A squared is 25, and b squared in this case is 4. So we're going to say, look, this is 25 minus 4, which is 21. So that means that c is equal to square root of 21. Okay. So now let's find the coordinates of the foci. So if you notice here, y'all, right here it tells me the coordinates of the foci. The foci is going to have coordinates C0 and negative C0. Everybody agree this is going to be square root of 21, 0 and negative square root of 21, 0? Hello. Okay. So we found the foci, we found the center. Now we need to find the vertices. Okay. So first thing, y'all, we're going to have two sets of vertices. We're going to have the vertices that are the endpoints of the major axis, and we're going to have the vertices as the endpoints of the minor axis. Okay. So look at the major axis. Remember what we said? We already know that a squared is equal to 25, and we know b squared is equal to 4. So the vertices have points a0 and negative a0. So what we need to figure out is, if we know that a squared is 25, what would a be equal to? 5. Yeah, but remember, it's just going to be 5, because remember, at the very beginning, I'm going to scroll back over here so you can see this. At the very beginning, remember what it said? A and B are both positive, right? A is bigger, but A and B are going to both be positive. So we're only interested in the positive value, okay? Now let's do the same thing for B. What would B be equal to if B squared is equal to 4? 2. There you go. Okay, so now that we have that, let's go ahead and write out our vertices. So we're going to have 5, 0 and negative 5, 0. And then for the endpoints of the minor axis, we're going to have, it says right here, y'all, 0b and 0 negative b. So it's going to be 0, 2 and 0 negative 2. Okay. All right. So now what we're going to do, we found the center, we found the foci, we found the vertices. Let's see if we can graph this thing. Okay, so I'm going to zoom in just a little bit. Okay. Y'all remember what we said the center of this thing was? 0, 0. Okay, so I'm going to put my point here. There's my 0, 0. Okay, now let's plot our vertices. So I'm going to plot the vertices, which are these red and these green points. So 5, 0 would be 1, 2, 3, 4, 5 over here. 1, 2, 3, 4, 5 over here. And then 0, 2 would be up here. And 0, negative 2 would be over here. Okay. And so what I'm going to do now, y'all, is I'm just going to connect my dots. Okay. So there's my ellipse. I know it's a little flat, but you get the idea. Okay. Second thing, y'all. Let's see if we can plot these coordinates here. Square root of 21, 0 and the negative square root of 21, 0. Okay, so I want to know roughly what my foci, when I plot them, right? I know these are the coordinates of the point. But what I'd like to know is roughly where would I find those points on my graph? Okay. Question. Anybody have a calculator? Can you roughly estimate what is the square root of 21? Give me a decimal approximation. It's got to be like 4 and change. I know that. 4.58. So let's do it like this. Let's say it's 4.60 and negative 4.60. Okay, so I'm going to zoom in here, y'all. And I want us to think about where those points would be. 4.60 and negative 4.60. Do y'all remember what the coordinates of these points? Oops, come on, man. Do you remember what the coordinates of these points were right here? Yeah. So this was 5, 0, and this was negative 5, 0. So 4.6, I don't know, maybe right about there, and maybe right about there. Okay. And there's our ellipse. Okay, so guys, one thing I'm going to do, and again, when you do your homework, really what they're going to ask you for is, can you find the center? Can you find the foci? Can you find the vertices? Can you draw the graph? So yeah, we can do that. I want us to go back real briefly and look at the definition of an ellipse. So look what it says right here. It says an ellipse is the set of all points x and y in a plane so that the sum of the distances between x, y, and two fixed points is a constant. The fixed points are what we call the foci. Okay, so I'm just kind of, let's see if I can get a good pen. Here we go. I'm just kind of looking at this part right here, okay? And I want to explain what that means. What that means is when I come back and I look at my graph, okay, and I pick, say, a point right here. That's a point that's on my graph, okay? I'm going to draw little line segments from that point to the foci. So I'm going to draw one here, and I'm going to draw one over here, okay? Now, again, this is just, again, when you're doing your homework, it's not going to ask you to do this. I just want you to kind of have visually what this means, okay? Now, we're going to pick any other point on on this graph, okay? Any other point. So I'm going to come, oh, I don't know, what point should I pick? Should I pick this one here, this one? Let's pick this one. Let's pick this vertice here, okay? If I pick that point there and I draw little line segments to the foci, what this is telling me is that if I were to take these little blue line segments, take those distances and add them up, it would be the same thing as if we took these little green line segments and added them up. And it doesn't matter what points we pick. Okay, that's what the definition of an ellipse is.
So long as it's on the line.
It has to be on the graph, right? Because we're talking about all the points x and y that are on that graph, right? We can't pick any random point. It has to be on the graph itself. But that's what the definition of an ellipse is. Okay. All right. So now let's take a look at the second problem. It says we're going to graph the ellipse. We want to find the center, the foci, and the vertices. Okay, so what I want you to notice about this problem here, y'all, compared to the one we had before, when we looked at this equation right here, it was real similar to the way this one looked or that one looked, right? So notice what we have. We have x squared over a number plus y squared over a number is equal to 1, right? That's the form we're trying to get to. And we don't have that just yet. So the first thing I'm going to do, I'm going to take my calculator, and actually I'll do it this way. If I wanted to get a 1 over here, what would I have to divide everything by? Let's divide everything by 441. Okay. So we know on the right side, we're going to end up with a 1. We know that part. So 9 over 441. Oh, I don't know. Let me turn this thing on. Okay. 9 divided by 441. What is it? I don't know. Let me see if I can make it to a fraction. Oops. I'm sorry? Yeah, it's 9y squared. But what I'm trying to do is I'm just trying to reduce 9 over 41, right? So look, if I go math and I go fraction, look what we get. We get 1 over 49. So this is telling me that this is y squared over 49, right? And then so wouldn't 49 over 441 be 9 down here? Right? So we know that 9 times 49 gives us 441. All right. So take a look now, y'all. If I look at this equation right here, right? X squared plus 9 squared, or x squared over 9 plus y squared over 49 equals 1. So what I'm going to do is I'm going to zoom back up here to the top, okay? And I'm going to write that down over here on the side. I'm going to say x squared over 9 plus y squared over 49 is equal to 1. And I'm going to look at this here, and I'm going to look at these two. And I'm going to ask you a question. Does it look like our major axis should be the x-axis or the y-axis? And I want to remind you that the number a is bigger than the number b. So is the number bigger under my x or under my y? Under my y. So if the number is bigger under the y, it's going to be like this one, because notice where the a squared is here, right? So this is telling me that, hey, look, my a squared is 49 and my b squared is 9. Does that make sense? John, am I doing okay so far? Yeah, we're good? Okay, just checking with you guys. All right, so look, let's come back over here. So we said our a squared was 49 and our b squared is equal to 9. First thing we want to do, we want to find the center of our ellipse. So the nice thing about these here, y'all, the center is going to be 0, 0. I'm going to show you when the center isn't 0, 0, okay? All right, second thing we're going to do, we're going to find the foci. So I'm going to scroll back up here where we were, and here's the definition of, or here's the formula for finding my foci. It says c squared equals a squared minus b squared, and then in our case, the foci is going to be at points 0c and 0 negative c. Okay, so what I'm going to do right here is I'm going to say foci is c squared equals a squared minus b squared And this is what our coordinates should look like. All right, so let's see if we can do this. C squared equals A squared, which is 49 minus 9. So that's 40. So C has to be the square root of 40. And I bet you we can break up the square root of 40, right? So when I think of 40, I think of 4 and 10. And do you know what the square root of 4 is? 2. Right? And the square root of 10, I can't simplify, so I'll leave it as 2 square roots of 10. Okay. So my foci, y'all, are going to be 0, 2 square root of 10, and 0, negative 2 square roots of 10. Okay. So we got our foci, right? Let me just kind of highlight those points there. Okay, we still need to find our vertices. So again, what I'm going to do, I'm going to scroll back up to the top. Okay. And I'm going to look at this part right here. So for our major axis, it's going to be 0a and 0 negative a. And for my minor axis, it's going to be b0 and negative b0. Okay, so let's do this. We're going to go with the major. It's going to be the points 0, 0a and 0 negative a. And then for the minor, it's going to be b0 and negative b0, right? Okay, so let's take a look here. If we know that a squared is 49, y'all agree with me that a is 7? And if b squared is equal to 9, we're good with b being equal to 3? Okay, perfect. So look, now we can write out our major vertices. So 0, 7, and 0, negative 7. And then for the minor, it's going to be 3, 0, and negative 3, 0. Okay? All right. So now that we have that, we're going to go ahead and start doing our graph. Remember, center of this thing, y'all, is right here at 0, 0. I'm going to go ahead and plot my major vertices and minor vertices. So 0 and 7. So 0 and 7 is going to be up 1, 2, 3, 4, 5, 6, 7, right about here. And 1, 2, 3, 4, 5, 6, 7, right about there. Okay. And then 3, 0 is 1, 2, 3. 1, 2, 3. And now what I'm going to do, I'm going to do this one in green just because. Oh my God, that's horrible. Let's try that one more time. Still not great. You kind of get the idea. Okay, so there's my ellipse, right? All right, foci. So here is our foci. Would somebody do me a favor? If you got a calculator, what's the square root, or what's 2 square root of 10? Decimal approximation, 2 square root of 10? Anybody? 6.32. Okay, so let's go 6.3, 6.3 with a negative. Okay. So again, y'all, remember when we had these points here, let me get my pen going again. It's freezing up on me. Okay. This was a point 0, 7. This was 0, negative 7. This was 3, 0. That was negative 3, 0. So 0 and 6.3 would have been right up there and right down there. And those are the foci. And again, all that means is that if you pick any point on that green ellipse, right, and you draw little line segments going from your point on the green ellipse to those foci, and then you pick another point anywhere in that green ellipse, and you measure the distance to those foci, when you add those values up, they're going to be the same, right? And that's really what an ellipse is. Okay. All righty. I'm sorry? Oh, I put them at they're just real small. Right in here, right down there, because it's at 6.3 and negative 6.3. So there, you can see that in both cases, they're really close to those vertices, aren't they? They're just like a hair away. All right. So let me scroll a little bit further. Okay. So now we can figure out what happens when the ellipse is not centered at the origin. Okay, so this right here, y'all, tells me the standard form of an equation with an ellipse that's centered at some point h and k. All right, the process is still the same. The only thing I want you to notice that's different is that now we have x minus h quantity squared and y minus k quantity squared. The a squared and the b squared are still the same, right? Remember, if the a number is bigger, then it's going to look more like this, right? It's going to be elongated more horizontally. If the number under the y squared is bigger, then it's going to be elongated more vertically, right? Something like that. Okay. So graph the ellipse, identify the center, the foci, and the endpoints of the minor axis. Okay, so what we're going to do here, y'all, we're going to do a little stare and compare. Okay. So yes, this is going to be a major axis. On the x, it's going to be more like this one. Okay, so what we're going to do is we're going to look at this one here, y'all. We're going to look at that one, and I'm going to ask you a question. Anybody know what the center of our ellipse is here? So the center is the point h and k, okay? So let me put it like this. The center are the points h and k. So what we want to do is we want to look at this piece here and look at this piece here and look at that piece there and look at that piece there and say, okay, can I see what h and k would actually be equal to? All right, see how here, see how this is a minus h, y'all? And see how I got a plus 2? I want you to think about it like this. Could I write it as x minus a negative 2 squared? And if I was comparing that to, if I was comparing that to x minus h squared, wouldn't we say h is what number? Negative 2? Does that make sense? Yeah, we're good? Okay. So h is negative 2. Now look at the next one. It's y minus, y minus k squared, and we have y minus 3 squared. So wouldn't we say k is the same thing as the number what? 3? Positive 3, right? Because it's a minus k and we have a minus 3. So k and 3 are the same. So think about it this way, y'all. The easy breezy Hyperbola way of doing this, whatever signs you have inside the parentheses, you're going to change it. So if it says a plus 2, you're going to put a minus 2. If it says a minus 3, you're going to put a positive 3. And it's always going to work that way. Okay. So notice we found the center of our ellipse, right? Okay, so we got the center done. I'm going to highlight this part because we got that part done. Now we want to find the foci. Notice this part right here, y'all, still the same way. It's still c squared equals a squared minus b squared. Okay. So look over here on the side. I'm going to say, look, to find my foci, c squared is a squared minus b squared. And when we're looking at our particular problem here, I'm going to get rid of some of this mess because I don't need it right now. Okay. But would you all agree with me that a squared is 16 and b squared is 9? So that means that c squared is going to be 16 minus 9. And isn't 16 minus 9 7? And so c is equal to the square root of 7? Okay. Okay, so we found the value of c. Now we actually have to find the coordinates of the foci. So look right here, y'all. I'm going to put foci, and I'm going to copy this part down right here. The way we write our foci, it's going to be h plus c and k, and then h minus c and k. Okay. So do you remember what we had for our h value? Wasn't our h value a negative 2, plus c, which is the square root of 7, comma, k, which was 3, and then h, which was negative 2 minus the square root of 7, and then our k value, which again was 3. Okay. So here is the coordinates of our foci. Okay. Now, we want to find the endpoints of, in this case, it says the minor axis. We're going to do both of them, y'all, because we need to do both of them so that we know what our graph looks like. Okay. So first, let's do the major axis. Okay. So I want you to look right here. The major axis is going to be h plus a and k, and h minus a and k. So we said h was a negative 2. A, let me ask you a question. If a squared is equal to 16, do y'all agree that means a is 4? And if b squared is equal to 9, that means b has to be equal to 3? Okay, so we're going to go negative 2 plus 4 and k, which was 3, and negative 2 minus 4 and k, which was 3. So this is going to give me what's negative 2 plus 4 is 2, 2, 3, and negative 6. Okay. Let's do the same thing, y'all, for the minor axis. So for the minor axis, y'all, and again, I'm just going to do a little copy and paste. I'm looking at the formula right there, and it says it's h, and then k plus b, and h, and k minus b. Okay. So we already know that our h was a negative 2. K happened to be, k happened to be the number 3. B was also 3. And then h, which again was negative 2, k was 3, and b was also 3. So this looks like it's going to be negative 2 and 6, and negative 2 and 0. Okay. All right. So first thing is the center of our ellipse. The center is at negative 2 and 3. So wouldn't that be 2 spaces to the left and then 1, 2, 3 up here? Okay. Let's go ahead and plot the vertices of the major axis, which is 2 and 3, which is 1, 2 to the right and 3 up. And negative 6, 1, 2, 3, 4, 5, 6, and 3 up. Here we go. And then let's go ahead and plot the vertices on the minor axis. So negative 2 and 6, so negative 2 and 6 is 1, 2, 3, 4, 5, 6 up here. And negative 2 and 0 is right over here. And then again, all I'm going to try to do, y'all, is draw this as nicely as I can. It's probably not very nice, but you kind of get the idea. Looks like a little boulder. Okay, and then I'm going to ask y'all for one more thing to help me with. I want to just know where the foci are. So if I were to plot them, take a look at what we have here. We have negative 2 plus the square root of 7. So y'all, I'm going to grab my calculator and I'm just going to say, okay, what is that going to be? Negative 2 plus the square root of 7. What is that? I'm coming up with about 0.6. Okay, so I'm going to say this is 0.6 and 3. And then negative 2 minus the square root of 7. and I'm coming up with like negative 4.6. Okay, so 0.6 and 3. So if I were to zoom in here, y'all, 0.6 is, I'm not even going all the way, going just a little bit, right about there. And negative 4.6, 1, 2, 3, 4, and a little bit more, right about there. And that's where my foci would be. That little doggy. Let it do the dog part. There's our ellipse, okay? So for the most part, y'all, this is pretty straightforward and figure out like how to find the center, the foci, the vertices, because all I'm really doing is I'm kind of coming back and referring to this, right? And again, you know, we could do the same thing where we said, look, let's pick a point on that, and if you measure the little distances to the foci and add those up, and you pick another point, you measure those and add them up, they would be the same. Okay. All righty. So we got one more problem to do here. Let's see. And it says, write the equation of the ellipse in standard form, identify the center, the foci, and the vertices. Okay, so when I look at this equation here, y'all, everything is just kind of jumbled together. So this is what we're going to do. We're going to rewrite the problem, and we're going to group pieces. So what I mean by grouping pieces, I'm going to put all the x terms together, and I'm going to put all the y terms together. So I'm going to do it like this. I'm going to put 9x squared. Then the other term that has an x is an 18x, okay? And then I'm going to save a little bit of space here because I'm going to do something in a minute. Plus, I'm going to put the y terms together. So we got a 5y squared, and then, what is that, a minus 30y? I'm going to put a little space here, and I'm going to move that 9 to the other side. Y'all agree with me? When we move that 9 over, it's going to become a negative 9? Okay. But do you agree that it actually is a negative 9? When we move the 9 over?
Yeah.
Right? Because we're crossing an equal sign, the sign's going to change, right? Okay, I'm going to ask you a question. Look at the first two pieces. I don't want to factor out a variable. I just want to factor out a number. What's the biggest number I can take from 9 and 18? What's the biggest number that factors? What's the biggest number that divides both into 9 and 18? 9. Okay, good. So we're going to go like this, 9. And then we're going to write it as x squared plus 2x plus, and I'm going to put a little space there, okay? We're going to do the same thing here, y'all. Can we factor anything out of 5y squared and 30y? Again, I don't want to factor out a variable, just a number. 5, good. And then we're going to have, let's see, y squared, everybody agree minus 6y? I'm going to leave a little space here, is equal to negative 9. Okay, what we're doing here, y'all, we're doing a process called completing the square, okay? And I'm going to explain the process of completing the square. What I really want to have is, remember when we think about the form of our ellipse, it's x minus some number, and the whole thing is being squared because it's a perfect square, and y with another number, and the whole thing is squared because it's a perfect square. That's what we're trying to get here, okay? So on the side, this is what we're going to do. We're going to complete the square with those two pieces. So over here on the side, y'all, I'm going to write x squared plus 2x, okay? The way we complete the square is we take the number that's in front of the x. In this case, it's 2, okay? We're going to divide it by 2. Always divide it by 2, okay? So I'm taking the number in front of the x. We're going to divide it by 2. We get the number 1. Then we're going to take the number 1 and we're going to square it. When we square 1, what do we end up with? 1. Okay. When we do that, we can factor this, y'all, into x plus 1 all squared. That's how you complete the square. Okay, so you can say, look, okay, you take the number in front of the x, divide it by 2. Always divide it by 2. Not necessarily, not because this is a 2, but you always divide it by 2. Okay, then whatever number you get, you square it, and you're going to add that over here. Now, if you do that, that part factors into x plus 1 squared. And you say, well, hold on, how do I know it factors into x plus 1 squared? Don't just trust me that I'm telling you the truth, right? But remember, you could do this on your own. You could say, look, remember, the number in front of the export is now 1. What's 1 times 1? 1. What two numbers multiply to 1 and add up to 2? 1 and 1. And if you have it as, and remember what that means. That means you would write x plus 1 and x plus 1, which is the same thing as x plus 1 squared, right? Okay, we're going to do the same thing for the y. So look, I'm going to take this part over here, and I'm going to do it on the side. Y squared minus 6y. Remember what we took? We took the number in front of the what? The first time we took the number in front of the x, right? So we're going to take the number in front of the y, which is a negative 6, right? It's negative. We divide it by what number? Very good. What number do you get? Okay, oops. Negative 3. Now, we're going to take that number, negative 3, and what are we going to do with it? Remember? We're going to square it. What number do we get? 9. Right here. This is a plus 9. Okay. Now, this part right here, y'all, is going to factor into y minus 3 squared. And you say, okay, how do I know that's going to happen? Because the number in front of that y squared is a 1. And 1 times 9 is 9. And what two numbers multiply to 9 but add up to negative 6? Negative 3 and negative 3. Okay. And again, that's the process of completing the square. So look, I'm going to show you all something. We're going to come back to our original problem, right? Where's my original problem? All the way over here. Okay, and I'm going to zoom out a little bit just so you can see, and I'll zoom back in. Do you remember what number we added over here? Okay, so right here, I'm going to put a 1. Okay. And do you remember what number we added over here on this one? Okay. So over here, I'm going to add a 9. Okay. I'm going to zoom back in. Now, I want to ask you a question. Remember what an equation means? Think about like back when you're in probably junior high and you start talking about equations. Equation means that one side is equal to the other, right? So if you put a number on one side, you got to put it on the other side too, right? Didn't we just add a 1 inside those parentheses, right? And then didn't we add a 9 inside those parentheses? So the fact that we added those numbers in means that we have to do something to now the other side so that this thing will still be equal. Now, I want to show you something, y'all. I know inside we put a 1, but what number did we have on the outside? So what number did we really add to the left side of the equation? We really added a 9, right? So that means if I add a 9 on the left side, I'm going to have to add a 9 to the right side. Jennifer, am I doing okay? Did I lose you? Okay. So remember what we were saying before? When you have an equation, if you introduce something new, like if you put a plus 3 here, we'd have to put a plus 3 on the other side. Okay. So we put a plus 1, right? But what did we really have in front of that? So we really didn't add a 1, we really added a 9, because if I were to distribute that 9 all the way through, it's like we've added a 9 to the left side of the equation, right? Like if I were to multiply that 9 all the way back in, I really added a 9 on this side. So then I have to add a 9 on the other side as well. So we're going to do the same thing. Yeah, we haven't finished it. We're just doing the first part. Now I know we put a 9 here, but because there's a 5 in front, when I multiply 5 times 9, that really means I added a 45. So I'm going to have to add a 45 over there as well. Okay. Okay. Now we're almost done, y'all. I'm going to put a 9 right here. Remember I told you that when we did this piece here, we were really completing the square, and we could have written this as an x plus 1 squared. And when we did this part here, we really factor that. We could really factor that into a y minus 3 squared. Now, I want you to look at the right side. What's going to happen with those 9s? They're going to cancel out. So let's get rid of them. We only have now a 45. Okay. All right, we're almost done. Now, remember when we're doing these things here? When I'm thinking about my ellipse in standard form, y'all, I'm going to come back over here. I want you to think about my ellipse in standard form. The number that I always have on the right side is what number? A 1. Okay, so let's come back to where we was, wherever we was, over here. Okay, and if we want to get a 1 on the right-hand side, what are we going to divide everything by?
45.
45. 45. 45. Okay. So we're going to end up with x plus 1 squared over how much? Very good. Plus y minus 3 squared over how much? 9. What did I put a 4? I don't know. Is equal to 1, right? Okay. We got this part done. All right, now let's take a look. What are we trying to do? We want to find the center, the foci, and the vertices. Okay. So let's take a look, see if we can find the center. Remember what I told y'all before? Whatever signs you see here, just change them. What's the center of this? Very good. You got it. Easy breezy cover girl. -1 and 3. Okay. So we got this part done. Okay. Now let's find the foci. Okay. So remember, y'all, the formula for the foci is c squared is a squared minus b squared. Now I got to figure out what's my a and my b, or my a squared and my b squared. Remember, c squared, y'all, is going to be a positive number. Easiest way to think about this, which is the bigger of the two numbers on the bottom? Okay, so a squared is equal to 9, and b squared is equal to 5. Okay, so we're going to say c squared equals 9 minus 5. 9 minus 5 is 4. So everybody agrees C has to be 2? Okay. All right, now let's see if we can find, how do we find the coordinates of the foci? So look, y'all, in this case, our major axis is going to be vertical because the bigger number was under the y, right? So look, we already know our center. The foci is going to have points h and k plus c and h and k minus c. So I'm going to come back over here. Foci is going to have h and k plus c, and then h and k minus c. That part there. Okay, so we know that this is going to look like this. -1 and 3 plus 2, and -1 and 3 minus 2. So -1 and 5, and -1 and 1. Here's our foci. Okay. All right, now we need to find our vertices. Okay, so let me scroll back up to the top. Here we go. For the major axis, it's going to be h and k plus a, and h and k minus a. Okay, so let's do this. We're going to go, we'll do this a little bit on the side over here. So we're going to find now our major. H and k plus a, and h and k minus a. Okay, so we already know that our h is -1. -1, k was the number 3. Let's see, a, guys, if a squared is 9, y'all agree that a is 3? Okay, so plus 3 and -1 and 3 minus 3, so this is -1 and 6 and -1 and 0. So we got our major, the vertices of our major axis right there. Now we want to do the same thing for the minor. Yes. Yeah, I know it got a little messy there, didn't it?
Yeah.
Yeah, sorry about that. There we go. Okay, so let me scroll back to find the one for the minor. So look right here, y'all. For the minor, it is H plus B and H plus B and K and H minus B and K. So, oops, where am I? Here we go. So for my minor, it's H plus B and K and H minus B and K. Okay, so H we already know is -1 plus, what is B? So if B squared is equal to 5, what would B be equal to? Just the square root of 5. Very good. So -1 plus the square root of 5 and 3, and then -1 minus the square root of 5 and 3. Okay. And so I'm just gonna do a decimal approximation, y'all, just so that I know when I'm gonna plot this where I'm gonna put that value, right? So let's do it like here. Let me grab my calculator. Let me turn this thing on. Oops. -1 plus whatever the square root of 5 is. I'm going to say 1.2. Okay, so 1.2 and 3. And then let's do the same thing again. Second entry, but let's change that from a plus to a minus. And -3.2. Okay. All right, so first things first, y'all, I'm going to go ahead and plot my major or center of the ellipse, which is -1 and 3. So -1 and then 1, 2, 3 right up here. And then for our major, we had -1 and 6 and -1 and 0. So -1 and 0 is right there. 3, 4, 5, 6 right up here. And then for my minor, it is 1.2 and 3. So again, I'm going to zoom in a little bit. 1.2 is just barely to the right. And 3, oh, that's not 1.2, that's 2.2. 1.2 would be right about there. And then, what was the other one? -3, -3.2. 1, 2, 3, right about there. Boom. And then my foci is -1 and 5 and -1 and 1. So 3, 4, 5, -1 and 1, right about there. And I will zoom in case y'all need to see that a little bit better. And -1 and 1. Yes, for the one before. Let's see. The foci was -2 plus the square root of 7 and 3, and -2 minus the square root of 7 and 3. And when we did decimal approximations, I came up with 0.6 and 3 and -4.6 and 3. What do you think? Ellipses you can handle? Not too rough? It's basically as long as you have that information there, like how do you find the center and the vertices and that kind of stuff.
minutes for a do my homework. No, I'm gonna have to see the video.
You can keep the video, or the other thing you can do, have this part ready. Because to me, once I know this part here, I'm just kind of following the steps, right? I'm trying to determine which is going to be, you know, is my major axis horizontal or is my major axis vertical? And then once I do that, then I'm just plugging and chugging in, right?
You probably separate this first element. I'm not
Probably.
gonna remember how to do this square. I'm gonna mess up on how to do it. I have to Google how to find the square.
Complete the square. Yeah. That's probably the hardest part, is doing that, completing the square process. Yeah. Yeah. And guys, you know, when you're doing your homework, if you come across a problem in your homework and you're like, sir, can you help me do the completing the square? Send me a picture of the problem. You know, I'll help you guys out. Ain't no big deal. Okay. So that was 10.1. Let's do 10.2, y'all. Let me get 10.2 ready here. Oh, here we go. And let's download this guy. And let's print this one as well. Here we go. See the current page. Boom. Okay, let me scroll. Huh? They're probably going to take some time to do, but yeah, we'll figure it out, y'all. Okay, so let's take a look here. Let me scroll back up here. Okay, so now we have a hyperbola. Okay, so remember before when we talked about an ellipse, and after we did our problem, I said, look, this is what an ellipse means. If I take a point on the ellipse, and I take two line segments, one measuring to one foci, one measuring to another foci, whatever those distances are, if I add them up, and then I take another point, and I do the same thing, and I add them up, those answers would be the same, right, when I add them. So let's take a look at what a hyperbola is. Hyperbola is a set of all points in a plane such that the difference in the distances, x, y, and two fixed points, the foci, is a positive constant, okay? So let's take a look now. It says a hyperbola consists of two parts called branches. The points where the hyperbola intersects a line through the foci are called the vertices. The line segment between the vertices is what we call the transverse axis, and the midpoint of the transverse axis is the center of the hyperbola. Okay, so we're going to, just like we did before, we're going to go through a problem where we have the center at the origin, and then we're going to figure out what happens when the center isn't at the origin. All right. I want y'all to take a look at the equations where we have the transverse is the x-axis and the transverse is the y-axis. The only thing that's really different, or in terms of the equation, excuse me, when we did an ellipse, we had a plus in the middle. Now we notice we have now we have a minus. All right. So let's take a look here. The equation is x squared over a squared minus y squared over b squared is equal to 1. The center is 0, 0. So the center, y'all, the hyperbola does not actually pass through the center, okay? It's going to pass through the vertices, but it's not going to pass the center. But it didn't, even in the ellipse, it didn't pass through the center, right? Okay, let's see. The foci is, the equation for finding the foci slightly different. C squared equals a squared plus b squared. We've seen that 101 times. And the foci is C0 and negative C0. Our vertices are A0 and negative A0. And then we have these things called asymptotes. And I'll explain what that means in a minute. Okay. All right. So these are, so here's an ellipse. These two here, y'all, are hyperbolas. This is what hyperbolas look like. Okay. So let's see if we can do the first problem here. And it says, if the variable term with a positive coefficient is in the x squared term, then the branches open horizontally. And if the variable term with a positive coefficient is in the y squared term, then the branches open vertically. Okay, to identify the asymptotes, first we're going to sketch a reference triangle with dimensions 2a by 2b, centered at the center of the hyperbola. The asymptotes are the lines through the opposite vertices of the rectangle. I'll explain what all that stuff means in a minute. The line segment passing through the center of the hyperbola perpendicular to the transverse axis and with endpoints on the reference angle is called the conjugate axis. All right, so let's see. Number one says graph the hyperbola. We want to find the center, the vertices, the foci, and the equations of the asymptotes. Okay, first thing is, let's take a look at this equation here. And I'm going to write it back up here where the other one was. So what is it? Y squared over 16, x squared minus 20 equals 1. Okay, question. Does it look like the transverse axis is the x-axis or the y-axis? The y-axis, because it looks more like this form where it's y squared over a number minus x squared over a number is equal to 1. Okay, so we know that it's going to be in this form. Let's find the center. So everybody agree the center is 0, 0? And now we're going to find the foci. So the foci, the way we do it here, y'all, it's going to be c squared equals a squared plus b squared. And I want you to notice, in this case, our a squared is 16, and our b squared is 20. Okay. So let's take a look. C squared equals 16 plus 20. C squared is 36. If c squared is 36, everybody agrees c is equal to 6? Okay. So the foci here, y'all, are going to be the points 0c and 0, negative c. So in this case, the foci is going to be at the point 0, 6 and 0 and negative 6. Okay. So we found our foci. Okay, and now we want to find the vertices. Do this in black. So the vertices in this case, y'all, are going to be at the point 0 and a and 0 and negative a. So question, if a happens to, or a squared is 16, what would a be equal to? So 0, 4, 0, negative 4. Okay. And let's take a look. We got another part here. We got to find the asymptotes. And again, I will explain what the asymptotes mean in a second. Let me write that a little bit better. Okay, so I want you to look right here, y'all, and I'm going to zoom in so we can see it. It says y equals a over bx and y equals negative a over bx. Okay, so since we knew that a squared was 16 and we knew that b squared was 20, that meant that a was 4 and b is the square root of 20, which we can simplify into 2 square root of 5? Yeah. Because it's 4 times 5 and we know the square root of 4 is 2, right? Okay, so this is what we're going to do, y'all. We're going to write out this. Y equals, and it says a over bx. And there's another one, y equals the negative of a over b with an x. Okay, so let's see if we can do this. A is 4. B is 2 square roots of 5 with an x. Okay. So what I really want to do first, John, before I do anything else, I want to simplify 4 over 2 square roots of 5. So do y'all agree that 4 goes into, or 2 goes into 4 twice? So this is really the same thing as 2 over the square root of 5. Do you remember how we rationalize denominators? It's been a long time since we've done it. What would I need to multiply the top and the bottom by? Square root of 5 here, square root of 5 here. So this gives me 2 square root of 5 over 5, right? Okay, so look, this is what we're going to do. I'm going to come back over here. I'm going to clean up this mess. Yeah, this is A over B. You're welcome. So look right here, y'all. I'm going to put A over B, or y equals 2 square root of 5 over 5 with an x. And the other one is y equals negative 2 square root of 5 over 5 with an x. Okay. Okay, I want you to do me a favor here, y'all, and I want you to look at the picture that we have right here. So in this picture right here, y'all, I know they didn't actually label it, but would y'all agree with me that that's the point B0, and this here would be the point negative B0? Does that seem to make sense? Right here, this point here and this point here, would you agree with me that those points are B0 and negative B0? Okay, so look, this is what we're going to do. We're going to come back to our particular problem, right? And didn't we say that since A squared was 16 and B squared was 20, A happened to be 4 and B happened to be 2 square root of 5? Okay. So, John, would you do me a favor? What is 2 square root of 5 as a decimal? 4.47? So let's say 4.5. Okay, so this is what I'm going to do, y'all. I want to find that point 4.5. So 1, 2, 3, 4 and a half. 1, 2, 3, 4 and a half. Okay, I'm going to do that. And then we said the point A was 4. So I'm going to go up 1, 2, 3, 4 up here. And 1, 2, 3, 4 right there. Okay, this is what we're going to do, y'all. We're going to draw a rectangle. The rectangle is going to look like this. What we're going to do is we're going to draw a line segment that goes through the corners. That's one line segment, or one line right there like that. And the other one is the one that looks like this. Okay. What those lines are, those are what we call the asymptotes. Okay. Remember we had two of them, and one was 2 square root of 5 over 5 with an x. And then the other one was negative 2 square root of 5 over 5 with an x. I'm going to do this one in green since that's the color that I was using. Okay. Let's see. We found our vertices, right? The vertices were 0, 4, and 0, negative 4. Okay. So the points 0, 4, and 0, negative 4, y'all, are these points right here. Okay. Now, what asymptotes are, they're kind of like borders, or kind of like fences. Okay. So what I drew here, y'all, I have a green line and I have a red line. The green line and the red line are my asymptotes. They're kind of like borders. So what happens is the graph kind of does like a little bowl shape like this, right? And then the idea is as I move further and further out this way, the graph gets really close to that line, but it never actually touches it. Yeah, you know, we did. That's right. We did go over it. When we did the tangent and the tangent and cosecant and stuff like that, we did go over that. That's right. Oh no, I didn't need to do that. Okay, let me draw this back here. Something like that, right? Okay. Yeah, we did go over asymptotes. I forgot about that. Okay, so right here and right here does this number. And the same thing is going to happen here. And the graph, that's right, we did go over asymptotes. So the idea is We get really, really close to those lines, we just never actually touch them. Okay? And then we found our foci as well, didn't we? What were the coordinates of the foci? We wrote it over here, 0, 6, and 0, negative 6. Okay, so the foci, I'm going to put it over here. Oops. 0, 6, and 0, negative 6. So let me zoom in again. If this is 4, 5, 6 would be here. 5, 6 would be here, and those are my foci. And the only reason I draw that rectangle, y'all, is so that I know how to draw my lines, how to draw my asymptote lines, okay? The rectangle is not actually part of the graph. It's just, it helps me draw those asymptote lines. There you go. All right. Are we still doing okay, y'all? Okay, take your time.
What are those dots outside?
The foci, because it's the point 0, 6 and 0, negative 6. That's right. Okay, so look, y'all, let's try the same thing here for the next problem. So it says we're going to graph the parabola, the hyperbola. We're going to identify the center, the vertices, the foci, and the equations of the asymptotes. Okay, so first thing we're going to do a little stare and compare. I'm just going to write my equation a little bit closer to what we have up here so that we can stare and compare it. X minus 4 squared over 9 minus y minus 3 squared over 7 is equal to 1. Okay, so first question. When we do a little stare and compare here, does my transverse axis look like it's going to be the horizontal or the vertical? And the way I do that, y'all, is I look at the equation that I have, and I stare and compare it to either this part here or this one here. Look more like the yellow or the green? What do you think? Which one's coming first, the X or the Y? The X, right? So it's got to be transverse axis is going to be horizontal, right? Because it's X minus a number squared minus Y minus a number squared instead of the other way around, right? Okay, so guys, just like we did before, the center is the point H and K, just like we did before, right? So remember, if I look at this problem here, what would you say the center of that hyperbola is? Anyone? Remember, we're going to do with these, remember what we do with those signs? We change them, right? So if it's negative 4 and 3, it's just 4, 3. There you go. Because look at the format. See how it's X minus and it's X minus? So wouldn't the H just be the number 4? And the K, wouldn't the K just be the number 3? There you go. All right, so we got the center done. So we found the center. We want to find the vertices. Okay, so the way we're going to find the vertices, y'all, and I'm just kind of going in order of what they're asking me to do here. So let's see if we can find the vertices. Okay, so the vertices is going to look like this. H plus A and K, and H minus A and K. Okay, so let's do a little stare and compare. Would y'all agree with me that A squared is equal to 9 and B squared is equal to 7? So that tells me that A is 3 and B is the square root of 7. Okay, so now look, we're going to find the vertices. It's going to be H, which is 4, plus A, which is 3, and K, which is also 3, and then 4 minus A, which is 3, and K, which is also 3. So my vertices are going to be at the points 7 and 3, and, oops, not negative 1, but positive 1 and 3. Okay. So these right here, y'all, are my vertices. So far, so good? Okay, now let's find the foci. So look, I'm going to over here, I'm going to write it down, foci. Okay, first I'm going to do, y'all, I'm going to write down the formula for the foci, and it says C squared is equal to A squared plus B squared. Okay, C squared is equal to A squared plus B squared. So let me write that down over here. C squared equals A squared plus B squared. And let's see. We know that our A squared is 9 and our B squared is 7. So we're going to say C squared is 9 plus 7. 9 plus 7 is 16. So wouldn't C be equal to the number 4? Okay. And so now that I know that C is 4, I'm going to come back and see how do we write the coordinates of the foci. It's H plus C and K, and H minus C and K. Okay. H plus C and K, and H minus C and K. So H was already the number 4, plus 4 and 3, and 4 minus 4 and 3. So this is 8, 3, and 0, 3. Okay. All right. The next thing we're going to do, y'all, is we're going to find the equations of the asymptotes. Okay. So what I'm going to do right here, y'all, I'm going to zoom in so we can find the equations of the asymptotes. And I want you to look at the equation right here. I'm going to copy it down first so we can use it. It's y minus k equals plus or minus b over a times x minus h. Let me write that down. Y minus k equals plus or minus b over a times x minus h. Okay, so remember, y'all, here is my h, here's my k, right? From the center, it's 4 and 3. So I'm going to say y minus 3 is equal to plus or minus, because I'm going to have 2 of them, right? B over a. Here's my a and my b. So my b happens to be the square root of 7 over 3 times x minus h. H was the number 4. So again, I really have two equations here, y'all. The first one is y minus 3 equals the square root of 7 over 3 x minus 4. And the other one is y minus 3 equals the negative square root of 7 over 3 x minus 4. Those are my asymptotes. Okay. All right. So first thing we're going to do, y'all, let's plot the center of this hyperbola. Remember what the center was? It was 4 and 3, right? Okay. So center was 4 and 3. So here we go. Let's go to the right 4. 1, 2, 3, 4. 1, 2, 3. There we go. Okay. So now that I have that, I want you to kind of look at this picture here, y'all. So see, here's my center. What I need to do is I want to find these points right here. And those are the vertices, right? So the vertices are whatever we got right here. I'm going to plot those points down. So remember what we said our vertices were? Our vertices were, here we go. We did it. 7, 3 and negative, I'm sorry, 7, 3 and 1, 3. Okay, so 7, 3, 1, 2, 3, 4, 5, 6, 7, and 3 right here. And 1, 3 is right there. Okay. What I'm going to do, y'all, is if I come back again and I look at this picture, here we go, right here, I want to be able to draw this kind of rectangle that they have right here. So we already have those points. The distance from here to here is the value of b, and the distance from here to here is also going to be a value of b. So what did we find out what our b number was? Our b number was what? Square root of 7. So can somebody tell me, calculator, square root of 7 is approximately how much? It's probably like 2 point something. 2 point something? 2.645, let's say 2.6. Okay, so this is what I'm going to do, y'all. From here, I'm going to go up 2.6. 1, 2, and a little bit more. 1, 2, and a little bit more. Okay. Now the reason I'm doing that, I'm drawing these little dotted lines. Okay. These little dotted lines are going to help me when I sketch my asymptotes. Okay. Are you okay with what I did? Or did I lose you? So no, I haven't plotted the foci yet at all. So all we did so far, John, if you look here in the middle, that's the center, right? And then we plotted this point over here earlier, and we plotted that point there earlier, right? These here are my vertices over here, right? And then look, I'm going to do these in red. These here in red, John, from the center, I went up 2.6, and from the center, I went down 2.6. So far, so good? Okay. The reason I'm doing that, I'm going to do my asymptotes. I'm going to do these using dotted lines, though. Okay, and I'm going to do them both in red, just because. Okay, there they are. Now, those are my asymptotes, right? So remember, y'all, we said that this one here was going to be, the transverse was going to be horizontal, so it's going to look roughly like that shape right there. Okay. So since we already know our vertices, let's go ahead and sketch the graph. I'm going to come back over here. I'm going to do it in blue. I'm going to go like this. You don't got to do the sound effects, but you can. Okay, there we go. Okay, now we can go ahead and plot our foci. So the foci, y'all, were right here, 8, 3, and 0, 3. I'm going to do those in green. So 0, 3 is right here, and let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 8, 3 is right there. And those are my foci. When you're finding the vertices, what you're doing is you're finding a point on that rectangle. Yeah. And then we're just going to, and so really what we're determining is, since the transverse axis here is horizontal, they're using those endpoints, right? Compared to the ones, like the ones that I did in red, if this thing would have been, the transverse axis would have been vertical, then those up there, those red points, Christian, would have been my vertices. Yeah. And again, the whole idea behind drawing the rectangle, y'all, is so that you can, number one, you see the center, right? And then number two, you can draw your asymptotes, right? And the asymptotes just go through the corners of those, they go past through the center and they go through the opposite corners of that rectangle there. All right, so guys, we got one last problem to do. We're going to graph the hyperbola. We're going to identify the center, the vertices, the foci, and the equations of the asymptotes. Okay. Question? I'm sorry? Oh, you got it? Good, good. Oh yeah, of course, of course. Okay, so look, y'all, this is what we're going to do for this one here. Let me try this first. Let's go like this. And here we go. And let me do a little snip, snip. Come back over here. And let's go here. Guess we got to go somewhere over here. Okay, so all I did is I just took a little screenshot, brought it this way so we can see what's happening. So do me a favor. Look at the equation that we have here. Let's see if I can get rid of this. I'm going to see if I can plot it somewhere else. Let's go here. Okay, let me do it. Let me put it there. Okay. Okay, so let's do a little stare and compare. This equation here, transverse x-axis or y-axis? Is it going to look like the number 1 or number 2? Oh, you know what? That's the wrong one. Sorry. Yeah, but that's the wrong one. Sorry about that, y'all. Okay. I just copied the wrong part. Oops. This is what we want here. Something looked a little bit off. Here we go. No, that was just my bad. No, because it's not in the right form, right? Okay, so yes, now we can come back here. Number 1 or number 2, and yes, I agree, it's number 2. Okay, so first thing we're going to do, let's find the center. Remember, the center is the point H and K. So one thing I want y'all to notice here, y'all, the y polynomial part, or the y component part, is coming first. It's y minus k squared over a squared. It's coming first. and then x minus h squared over b squared is coming second. But the h and the k are still the same values. So everybody agree that the h is -3 and the k is +5? Okay, so we got that part then. Okay, we found the center. Let's find the vertices. And I'm just going in order like what it's telling me here. So it says the vertices. So the vertices, y'all, since I'm using this part here, is going to be h and then k plus a and h and k minus a. Okay, so let's take a look here. We need to find a couple of things. Y'all agree with me that a squared is 49 and b squared is 25? And so that would tell me that a is 7 and b is 5? Okay. So let's see if we can find the vertices. Let's see. H is -3. K is 5 plus 7, and H is -3. K is 5 minus 7. So my vertices are going to be -3 and 12 and -3 and a -2. Okay. So far, am I doing okay? Okay. Okay, I'll slow it down. Okay, now let's go ahead and see if we can do the foci. Okay, so the formula for the foci, y'all, is c squared equals a squared plus b squared. So c squared is going to be equal to 49 plus 25, which is, I don't know, 49 plus 25, 64? 74. So c is just the square root of 74. Okay. All right, so now that we found a value for c, and since this is like number 2, that's what I'm going to do right there. My equations, the coordinates for my foci, y'all, should be h and k plus c, and h and k minus c. I'm sorry? No, I haven't written anything underneath it. Did you come up with c squared of 74? Yeah? Okay. So look, John, all I'm going to do is this part right here, right? H and k plus c and h and k minus c. So h and k plus c and h and k minus c. So here's my h and my k right there. So this is going to be -3 and, very good, 5 plus the square root of 74, and -3 and 5 minus the square root of 74, right? Boom, there's our foci. Okay. Alrighty, and I think the next part is asking us to do the asymptotes. So here's the equation on how we find our asymptotes. It's y minus k equals plus or minus a over b and x minus h. Okay. So let's go slowly here. Let's see. We're going to write y minus k. K was the number 5 equals plus or minus. Let's see. Here's my a and my b. So 7 over 5 x minus a negative 3. So we're going to change that to a plus 3. There we go. And I'm going to write out the two separate equations, y'all. So look, I'm going to write like this. Y minus 5 equals 7/5 x plus 3, and y minus 5 equals negative 7/5 x plus 3. I'm not saying that you can't write plus or minus. I don't know exactly how Alex is going to ask you to write it, okay? But if it says write two separate equations, then that's what I would write. If it lets you do plus and minus, then go ahead and do plus and minus. Okay? It's just a lot of times people forget plus and minus really means two things. One when it's positive, one when it's negative. When we write it down as one thing, sometimes people think it's one value or one equation or one number, and it's not. Okay. Okay. So we found the center, we found our vertices, we found our foci, and we found our asymptotes. Let's see if we can graph this thing. So guys, when I did this problem, I didn't put the little, XY axis on here, so we're going to draw one ourselves. It's no big deal. It's going to go like this. Again, you don't have to do this on a test. There we go. Okay. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 8, 9, 10, 10, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Okay. Let's start from the beginning. We got the center being the point negative 3 and 5. Okay. So my center, I'm going to do it in red. Negative 3 and 5 is 1, 2, 3 to the left. 1, 2, 3, 4, 5 up. Right about here. Okay. And let's see, what else do we got? We had a vertices. Vertices were the points negative 3 and 12. And negative 3 and negative 2. So negative 3 and 12, this was 5, 6, 7, 8, 9, 10, 11, 12. So somewhere right about there. And negative 2 right about there. Okay. All right. And then what was our value of B? Remember how B was the number 5, y'all? I want to show y'all something here. So this is basically what my graph is going to look like. It's going to look something very similar to this. So I want you to notice we've already plotted the vertices here. Okay? Here's the center. The distance from the center this way and the center that way, those distances are values of B. Okay? So if I come back to my problem, I know B was 5 because it told we figured that out right here. So if B is 5, I'm going to do this in green. This is 3, 1, 2, 3, 4, 5, right about there. And let's see, this is 3, 1, 2, 3, 4, 5, right about there. Okay, so the reason why I'm doing that, I'm going to do this in black. I'm going to draw my little rectangle. Something like that, right? And then I'm going to do my dotted line that goes through the center and the corners. Center should have been negative 3 and 5. Are the vertices? Right? And here is my graph. This ones on the left, those are just the dots that I was putting so that I could make my little rectangle, right? You know what I mean? And then I'm going to go ahead and plot, and I'm going to do my foci, y'all. So remember, my foci was right here. We found these numbers earlier. It just happened to be like square roots. So I'm going to figure out what is 5 plus the square root of 74 and 5 minus the square root of 74. So 5 plus square root of 74 is 13.6. So negative 3 and 13.6. This point here was 12, so 13.6 is a little bit more. And then let's do the same thing, except instead of plus, we're going to go minus 3.6, so negative 3.6, right about there. And those are my foci. Okay, so here was the center, right? The center was right here. Okay, remember when we did our vertices, the vertices already gave me those values right there, right? Okay, so the way I find the width is I come back over here and I do a little stare and compare. So from the center right here, the distance from here to there is the value of B. B was 5. So what I did, John, was when I came back here, I just went like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's all I did. So foci were the negative 3 and 5 plus square root of 74, and negative 3, 5 minus the square root of 74. So Jennifer, I just did that on my calculator, and the numbers that I came up with, when I added, I came up with 13.6. So it would have been negative 3 and 13.6, and then negative 3 and negative 3.6. And that's 10.2, y'all. So to me, the really what I'm doing in 10.1 and 10.2, I'm referring back to either this here for 10.2 or the one for the ellipse in 10.1, right? Something like this for the ellipse in 10.1. I'm just referring back to those things, and I'm trying to see if I can find my center, my vertices, my foci, and then draw my graph. So let me go ahead and stop recording because we are done with the lecture part. There we go. Nobody was